Bismillahirrahmanirrahim. Assalamu alaikum viewers, welcome to my channel, and in today's video you can see the heading. We are going to discuss here how to find out the area enclosed by a lemniscate with the help of the double integrals using polar coordinates. And as far as the geometrical interpretation of double integral is concerned related to the Cartesian coordinates comparison, we have just discussed that exhaustively in my previous video. You can see the link in the description box below. So if you want to view that video, you can easily just simply click on the link and the video will be right in front of you. So now we are going to move and we will apply here double integrals and try to find out the area enclosed by this lemniscate. Equation of the lemniscate is mentioned over here. This is it. So first of all, what we do, the major object or the major requirement is the assignment of the limits of our theta and r, which are the two major polar coordinates. Okay, so how we assign the limits of theta and r? For that purpose, we have to sketch this lemniscate. So first of all, we just try to analyze its symmetry with respect to the initial line and with respect to the pole. Then we will try to maintain a table of the subjective polar coordinates, and then we will try to sketch the lemniscate. Okay, so first of all, what we do, we will try to check that whether this lemniscate is symmetrical about the initial line or not. Okay, so what we do here, this is the equation. If we replace our r theta, these coordinates, either by this or by this. If we try to substitute at the place of r theta this or this, then if the equation remain restored or preserved, remain unchanged, then we will say that the subjective curve is symmetrical about the initial line. And we know what exactly the initial line are. The line with respect to which we maintain the angle is called the initial line. The initial line is the line from where we just calculate the angle, from where the angle starts. Okay, so this is the initial line. Actually, this is it. Okay, so we are maintaining the angle with respect to this axis. So this axis is going to behave as the initial line, and the point with respect to which we maintain the angle is called the pole. So this is the pole. So that's exactly what we are dealing with. So if I just select at least one of these two. So how about if I just pick up this one? You can use this as well, it's your choice. I will replace my r in theta by r in minus theta. So it will be something like this. And we know that cosine is an even function. So if you insert a negative independent variable, then in return the output is going to be exactly same what you get in case if you put the positive variable. So you are getting same equation back. There is no change. So this shows that this curve is symmetrical about the initial line. Now let us check its symmetry about the pole. Now in order to check the symmetry about the pole, I'm going to replace my r theta coordinates either by this, okay, or by this, r and pi plus theta. So either I substitute this coordinate or this coordinate, then in that case, if the equation remain unchanged, then the curve is going to be symmetrical about the pole as well. So let us check, and I can pick up either this or this, my choice. So to save my time, I will pick up this. Now I will replace my r by my minus r, and theta is same. So as I am having square here, so you see my equation is preserved. So this shows that the lemniscate is symmetrical about the pole as well. All right, so this is going to help me in sketching the curve. Now the third thing is to assign the position of the pole relative to the curve. For that purpose, what we do, we just try to find out what is going to be the value of r when our theta is going to be 0. Okay, so if my theta is 0, then what is going to be my r? That's what I have to find. So at the place of theta, I will just insert my 0 here in the lemniscate equation. Okay, so we know well that the cosine of 0 is 1. So it becomes a square into 1. So r square is a square. Take square root. This gives you r is equals to a. So once when your theta is 0, then r is a here. Okay, well, let's try to establish here the table of contents. Okay, so these are the theta values that I've just maintained here from 0 to 180 degrees. All right, and these are in the form of degrees, and this is in the rads. You know that well. So how we are going to get the value for r with respect to these angles? So I'm just picking up my degree format to get a quick calculation. So it is, if I just put down my 0 here, as we have already done this thing in the position of the pole point relative to the curve, that if we put theta 0, the value of r is a. So we just write here r directly. As far as this is concerned, if I just put down over here 30 and it becomes 60, so cos 60 is half, so it becomes this. Once when I take square root at both sides, I'm going to get plus minus a upon under root 2. So I'm just going to pick up the positive value of r, because r is nothing but representing the magnitude of the radial segment. Magnitude is always positive, so that's how I pick up. It is a upon under root 2, or also you can write as 0.7 a. Okay, so it is this, a upon under root 2. So in this way, you just see over here at the place of your theta, if you put 45, then r square will becomes a square cos 2 times 45, which is cos 90, and cos 90 is 0. So this whole thing will become 0. So r is 0 here, you just write down 0. Okay, now as far as 60 is concerned, if we just insert 60, so twice of 60 is 120. So, and cosine of 120 is what? It is, I think, negative half. So it is negative half, so it becomes minus upon 2. So as you're having a negative thing, so take a square root. So it is going to give you an imaginary value like this. Okay, so that's what you're writing here. As far as 90 and 120 are concerned, you're also going to have a negative value with respect to these two angles as well. So let us write it directly. So it is, on substitution, give you 180, and cos 180 is negative 1. So it is negative a square. So it gives you iota a, right? And same way, 120 2 times give you 240. So cosine of 240 is once again half, negative half. So again, you're having this value. Okay, similarly, you just put down your 135 at the position. So twice of your 135 give you 270. Yeah, 270. Cosine of 270 is 0. Obviously, it comes on the negative y-axis. The cosine is 0 here, so whole thing gets 0. So r is 0. You just write 0. That's it. Okay, similarly, you put your 150 at this position. It becomes 300. So cos of 300 is what? It is half. Okay, so once again, you're having, on taking square root, a upon under root 2. All right, and you put 180. Let us do one more calculation. So you put 180 here. It gives you 360. Cosine of 360 is 1. So r square is a equals to a square. On taking square root, it gives you r equals to a. Okay, so this is it. So now the table of values is entirely done. Now the next step is to sketch or to plot theta and r on the polar plane or the polar coordinate system. Okay, so for that purpose, as far as a is concerned, a is not specified here, the value of a is not specified here. So once when we try to sketch the curve, and we are going to consider a as 1, so it will be helpful. So we are going to assume that let a is 1, and then we are going to plot these values of r with respect to these thetas, and that's it. So now you can see one more thing, that the values from 60 to 120 are giving you imaginary, the values are imaginary of r from 60 to 120. You are not going to consider these three angles on the polar plane. You're just going to draw the curve from 0 to 45, and then with respect to its symmetry on the initial line, you're going to draw the remaining part, the remaining 1/4 part, and in this way you're going to have a one complete petal. Okay, it will start like this. Okay, so you are going to draw just 1/4 part of the lemniscate from 0 to 45, and with respect to its symmetry about the initial line, you're going to complete its 1/2, and then with respect to the pole, you're going to get the another petal. So first of all, let us try to sketch from 0 to 45. So that's it. This is your polar coordinate system, a polar plane, and the angles I've just specified here, you can see. So it starts from 0 to 90 to 180 to 270, and once again 360. So that's it. So over here I've just tried to maintain two rays representing theta equals to 45 and theta equals to 30. So at theta 0, the value of r was a here. So I've just maintained a scale that I just said that I'm going to take my 4 centimeter equals to 1a. So my a position on theta equals to 0 ray is going to lie exactly at this point. Okay, right over here. So this is going to be my a. All right. Now for theta 30 equals to 30, the value of r was 0.7a. So what is going to be where I'm going to put my point here on this ray representing the radius. So you see, if I just multiply both sides by my 0.7, then 0.7 into 4 give you 2.8 centimeters. Okay, so from 0 to, I'm going to manage my 2.8, whatever it is going to be, that will be my point. Okay, and same story I'm going to do over here, that once when my theta was 45, the value of r was my 0. So simply 0 means it is going to come over here, 0 centimeter. I've just multiplied both sides by my 0, 0 give you 0, nothing else. Okay, so it is going to come over here. For this ray, the value of r is 0, so it is going to come over here. Now let me just manage my 2.8 over here. It is so it is, you can see it's 2.5678. yeah, it's here. Okay, it's done. So it is a upon under root 2. So let me write a bit ahead. It's a upon under root 2. That's it. But I'm going to manage a curve by joining these points, this, and this point. It is going to give me 1/4 of the lemniscate. Okay, so that's how it looks like. Okay, now with respect to its symmetry to the initial line, I will just draw its reflection exactly like this. So I will get one complete half of the lemniscate. That's how it looks like. So this is something that I have drawn with freehand on the basis of symmetry. Now, as this lemniscate is symmetrical with respect to pole as well, so if I just switch, oh, it's just an ink. That's an ink, okay. So if I just try to turn this petal over here by pivoting its edge at the pole, then it is going to rotate like this. I'm going to have another petal exactly over here. So because it is symmetry with respect to the pole, the same portion I'm going to have at this side as well. Okay, the same shape I'm going to get at this side as well. So that's something that I will draw the freehand as well, managing the symmetry. Okay, that's what I've done. I've just drawn this thing on the basis of symmetry, and that's it. So we are asked to find area of this complete lemniscate, this whole thing. So what should be the limit of theta and what should be the limit of your r? You see, if I just find out the area of my first petal, of just one petal of the lemniscate, and if I multiply it with 2, I'm going to get area of the entire lemniscate. That simple thing. So you see, as far as the area, as far as the limits of the theta is concerned, it is starting from, it is covering positive 45 and the negative 45. Okay, so the limit of my theta, or the range of my theta, is going to be from minus pi by 4 to positive pi by 4. Okay, and as far as the value of r is concerned, if I just focus on this petal, the value of r is starting from the pole up to this curve. Okay, so the value of r is starting from the pole up to this curve, and the curve definition is what? As the equation of the lemniscate is, if this, so if I take square root at both sides, so r is going to be a under root cos 2 theta. That's the story is. So it is going to be interpreted like this. The limits are now assigned, and now with the help of the double integral, we are going to find out the area. So the area of the lemniscate, half of the lemniscate. So, and as far as the area of the full lemniscate is concerned, I'm going to multiply that entire double integral with my 2. So in this way I will get the area of this complete lemniscate, because the double integral is just finding out the area of one petal. Okay, so it is from minus pi by 4 to positive pi by 4. R is going from 0 to a under root cos 2 theta r dr d theta. Okay, now I'm going to integrate first with respect to my r. Okay, so it is going to be, r square upon 2, and then we are going to apply our limits of r. That's better. So it's going to be 2 times. Now this is a regular integration that we are going to do. This 2 will go outside. It will be like this. Okay, and then just r square is left. We are going to apply the limits. It will be a under root cos 2 theta square minus 0 square d theta. This 2 and this 2 gets cancelled. So integral of negative pi by 4 pi by 4, it gives you a square cos 2 theta d theta. All right, now a square is a number thing, a constant thing. It will be written outside your beautiful integral. And now the cos 2 theta is left, and it is going to be, therefore you can make a u substitution if you want to, or also you can do a direct integration. So I'm just doing it directly. So it is sine 2 theta, whatever the angle is, we'll take the derivative in the denominator with respect to this variable. So it is 2. And now this 2 will go outside. It's just a preliminary integration. and then we apply the limit over here in this function, the upper limit minus lower limit. Okay, so that's it. And as sign is an odd function, so this sign will be preserved because will be written outside, because if in odd function, if you're putting a negative variable, then it's going to give you an answer like this. Okay, so this sign will be written outside. Also, you can check it through the calculators if you want to. And I'm sorry, it's 2. It's 2. Okay. And now it's sine pi by 2. Sine pi by 2 is 1. This sign is outside, it becomes plus. And sine pi by 2 is again 1. So it becomes 2a square upon 2. So it is a square. So the area of this full lemniscate is a square units. Square units. Okay, so that's it. So it's done. So you see, that's how the double integrals using polar coordinates helps us at several places wherever we need it. So area of the lemniscate has been just evaluated. It is just sorted out. So if you find this video helpful, I humbly request you to subscribe my channel, hit on the like, and share this video with your friends and other learners as much as you can. I'll appreciate that. And don't forget to put your comments or your feedbacks in the comment box below. And also, the last thing, don't forget to hit on the bell icon to get the latest updates. Take good care of yourself. I'll see you soon in the future with some more helpful videos. Allah Hafiz.